Hello, this is Lama Yunus, and this is my CCI presentation on gas laws in relation to thermodynamic engineering. Thermodynamics is a branch of physics that deals with the relationship between heat and other forms of energy. Particularly, it describes how thermal energy is converted to other kinds of energy and its effects on matter. Thermodynamic engineering is when thermodynamics is applied to mechanical systems such as an engine. Thermodynamic engineers are responsible for the testing, development, and design of products and machinery, much like the work of a mechanical engineer. Engineers are also in charge of evaluating a product for quality, safety, and cost. There are three primary gas laws: Boyle's law, Charles' law, and Gay-Lussac's law. There's also an ideal gas law. Each law has a use or application in the fields of chemical, mechanical, or thermodynamic engineering. Boyle's law was named after chemist-physicist Robert Boyle, who published the original law in 1662. It states that the volume of a gas at fixed temperature is inversely proportional with the pressure. Boyle's law is described using the relationship P1V1 equals P2V2, in which P is pressure and V is volume. Boyle's law applies to mechanical or automotive engineering. It's seen in steam engines, gasoline, and tire pumps, and airbags. For instance, before an airbag expands, it's compressed and pressure is high. When the bag expands, the pressure decreases and as the volume raises. So as the airbag increases in volume, the pressure decreases, and when the pressure increases, the volume decreases. Charles' law was discovered by French balloonist Jacques Charles in 1787. It states that the volume of a gas at a fixed pressure is directly proportional to its temperature. The relationship for this law is V1 over T1 equals V2 over T2, in which V is volume and T is temperature. Again, car engines are a great application of Charles' law. The heat from the combustion of the fuel causes the cylinder to expand, which pushes the piston and turns the crankshaft. Thus, Charles' law applies to engineering. Gay-Lussac's law was proposed by French chemist Joseph Gay-Lussac in the early 19th century. It states that the pressure of a gas at fixed volume is directly proportional with temperature. The law is described using the relationship P1 over T1 equals P2 over T2, in which P is pressure and T is temperature. Gay-Lussac's law can be applied to the engineering and manufacturing of not only tires, but also firearms, ovens, and water heaters. In a tire, when the temperature of the air rises, the pressure of the gas in the tubes increases. After an unbearable point, the tires fracture. The same thing happens with steam and a water heater. Therefore, Gay-Lussac's law is applicable to many objects and technology related to mechanical engineering. The ideal gas law was first stated by Emile Clapeyron in 1834. It's a combination of Boyle's law and Charles' law. The relationship obtained is PV equals nRT, in which P is pressure, V is volume, N is moles, R is the ideal gas constant, and T is temperature. Because it's simple to use and approximates real gas behaviors, the ideal gas law is used by thermodynamic engineers who work with gases. It provides important information regarding reactions such as the gas produced in a reaction and the mixing of gases. It is even useful in determining the efficiency and standard operation of equipment as well as the capacity of a storage container. The kinetic molecular theory made in 1860 explains all of the gas laws. German physicist Rudolf Clausius proposed that heat is a form of energy that affects the temperature of matter by changing the motion of molecules of matter. This kinetic theory of heat enabled Clausius to study and predict the flow of heat, a field now called thermodynamics. As you guys know, because of class, the modern kinetic molecular theory has 5 basic assumptions, and they're right there. In conclusion, I learned that gas laws and kinetic molecular theory are seen all around us, especially in cars. Engineers have to have a good understanding of the gas laws in order to know exactly what they're doing. I've also discovered a couple of interesting facts. One of them is that it's said that Gay-Lussac's work directly influenced Avogadro's law. I also learned that among other achievements, Gay-Lussac and 2 others decomposed boric acid by using fused potassium, thus discovering the element boron. And lastly, I learned that Clapeyron and Gay-Lussac's names are both one of the 72 names inscribed on the Eiffel Tower. And that's my bibliography. Thank you.